All right, before I start on the sine law, let's get a little bit of equation solving behind us here. In this case, on the left, you can see sine of 56 degrees over 68.3 equals sine of 47 degrees over m. If you look for the variable, m is not an angle. If it were an angle, then it would be sine of m, and it would be a capital of m. It would be a capital M. It's a lowercase m, which means it's a side length, but also it's not sine of that, so it's definitely a side length, not an angle. When you solve for this, we're just going to get m equals, and it's just going to give us a number. We're not going to have to do sine inverse. We're not going to have to do anything tricky. We're just going to put in our answer in our calculator. On the right-hand side, and I'll show you that in a second, I just want to kind of show you the difference. On the right-hand side, our variable is g, but it's not just g here, it's sine of g. G is now an angle, right? Angles aren't actually in these equations. There's only sine of the angle that's in an equation. You'll never see an actual angle in the equation. If you have an angle in your equation, you're either going to have sine of the angle, cosine of the angle, or tangent of the angle. So when we isolate g, we're going to get sine of g is going to be equal to like 0 point something. And then to find what the angle g is, you're going to have to do the sine inverse of that 0 point whatever it is. Okay, it's always going to be 0 point something. The highest it could possibly be is 1. Okay? So sine of g, that's when you're going to need your sine inverse. So right away looking at these things, I can tell you that I'm going to need to do sine inverse on this one because the variable is next to the sine here. It's an angle that we're looking for. And not this one. I'm not going to need sine inverse because sine of 56 degrees is easy to put in my calculator. Sine of 47 is easy to put in my calculator, and 68.3. You can put them all in, no problem. Right? And we're just going to end up with m equals that answer. Right? So on a triangle, you know that if you're trying to find an angle, you're going to have the extra step of sine inverse. If you're trying to find a side length, you will not have that extra step. So let's try solving them. The one on the left, you see the variables on the bottom, so we're going to flip that one upside down, both sides. So we're going to get 68.3 over sine of 56 equals m over sine of 47. On the right-hand side, the g is already on top, so we don't have to worry about that. All right, in both of them, we look for our variable. We cross out the thing that's underneath it, and we move it over to the other side. Make sure that when you move it to the other side, it goes to the top. So this sine 47 degrees must be even with the 68.3, not down there with the sine of 56. We're not dividing it, we're multiplying it. And similarly, the 75.9 has to go up to the top on the other side. So it's sine 64 degrees times 75.9. You don't want to put it down in the denominator. All right, on the left, we have sine 47 times 68.3 divided by sine of 56 degrees. As you can see, you can just throw that right into your calculator, and you end up with 60.25. So it's just 60.25 equals m. You're done. You found it. Whereas on the right-hand side, you have sine of g equals sine of 64 degrees times 75.9 divided by 80.6. So sine of g equals 0.8464 approximately. You see there, as I told you, it's always going to be a number between 0 and 1. Right? Sine of g is not what we want. That's where you have to do this thing. Now, remember, I want to keep, if you have that number between 0 and 1 and you have sine of g, recognize it. Keep 4 decimal places. Otherwise, your angle will not be correct most of the time. So make sure you don't just write 0.8 or 0.85. It's just, that's not enough. I want to see 0.8464. 4 digits minimum. Right? So then, now that we want to find g, that's when we do sine inverse of 0.8464 to see which angle it would be that where sine of that angle equals 0.8464. And it turns out that that is equal to 57.8 degrees. Make sure your calculator is in degree mode. All right, so there you have it. If you're looking for an angle, you're going to end up with sine of the angle with an answer between 0 and 1. If you're looking for a side, you're just going to straight up get the side length. If you are looking for that angle, you have that extra step of doing the sine inverse of that small number between 0 and 1. All right, now teaching the sine law should be easy once we know that. So I'm actually just going to use the exact same numbers on this triangle. All right, let's look up here. The sine law says sine of A over A equals sine of B over B. A couple of things to note. Capital A is always, the capital is always the angle. So make sure when you name your triangles, name the angles with capital letters. And there's a reason why A and A are together here and B are together here. It's because when you name triangles, you're supposed to, as much as possible, name the angle and the opposite side the same letter. And that's why it's important to make the angles capital, so we know that the capital one is the angle and the same letter but lowercase is the side that's opposite. They have to be opposite, and that's really important for this equation. Capital P opposite to lowercase p. And if I were to name this side here, I'd call it lowercase n. It says 68.3, so I really don't have to name it, but it would be lowercase n, capital N. So if you notice in this equation, they specifically put A and A together. That means this equation only works if the angle that you use is divided by the side that happens to be opposite to it. So this one here, if you use the sine law and you said sine of 47 degrees divided by 68.3, that won't work. That's not the correct sine law. If you say sine of 47 degrees divided by p, that will not work. It's not the correct sine law. You have to say sine of 47 degrees divided by m in your equation. Sine of 56 degrees can't be divided by m or p. It has to be divided by 68.3. It's B and B, A and A. So it has to be the opposite side and the opposite angle. All right, step one for doing the sine law. Find an angle and its opposite side, making sure that we already know the value of both of them. If you can't do this, then you can't use the sine law. All right, so let's look. Where I see capital P, I don't know this angle, although I could find it pretty easily. Lowercase p, I don't know that side. Well, this is definitely not what we're going to use because we don't know both. So as a matter of fact, right now we don't know either. I have 47 degrees here, that's good, but I don't know what m is. Okay, that's not what I'm going to start with. I have 56 degrees, and I do know what's this side, which is 68.3. So I know the side length, and I know the angle, and they're opposite to each other. We can use the sine law here. All right, so we're going to start with that, and we're going to say sine of 56 degrees divided by 68.3. And sure enough, that's what I have right here. Sine of 56 degrees divided by 68.3. Okay? Step 2. Step 2 says find another opposing angle and side, making sure that we already know one value but not the other. And so we're going to look here. Now I know that we already found the two that we know. We're 56 and 68. Let's try 47 degrees opposite to m. We do know one of them. We don't know the other one. That satisfies step 2. The reason we're doing that, we want to know both of them to go on the left side. Since we know both of them, there will be no variable. Then we want to know one of them, but not the other. That way we're going to have one that's not a variable, the other that is a variable. That way our equation will have only one variable in it. All right, so we have sine of 47 degrees over m, and that goes on the right. All right, so there we go. Sine 56 over 68.3, sine of 47 over m. We made sure a bunch of things. 56 degrees is opposite to 68.3. Super important. If you did your work and that's not what you did, change that. You're going to have to redo your work because your answers won't be correct. Sine of 47 over m. 47 and m are opposite to each other. Okay, and now we just go back to how I solved it before. Because the m happened to be on the bottom, you can just switch it up. So you're going to say m over sine of 47 is equal to 68.3 over sine of 56. The thing that's under the variable we cross out and throw over to the other side, and then we simply say m is equal to sine of 47 degrees times 68.3 divided by sine of 56 degrees, about 60.25. So now we know that the side m has the side length of m is about 60.25. Of course, with this triangle, we have to go a little farther because we still don't know capital P or lowercase p. So let's do that quickly. For capital P, we already know two angles, so we can easily find the third angle. Capital P equals 180 degrees minus 47 degrees minus 56 degrees. So capital P is equal to 77 degrees. All right, now we can go back to our sine law. Step 1, find an angle and its opposite side, making sure that we know both of them. 56 degrees and 68.3. Same pair, we know both of them. So we can write sine of 56 degrees over 68.3 equals. Now we find a pair where we know one but not the other. So we have, let's see, 47 degrees and 60.25. Nope, we know both of them, so that's not going to do. It won't be useful if I don't have any variables in my equation. Let's try this one, 77 degrees and lowercase p. Aha, I know the angle, I don't know the side. That's what we're looking for. So we're going to say sine of 77 degrees divided by p. All right, quickly double check that we did step 1. We found an angle and its opposite, and we put that on the left. 56 and 68.3 are opposite to each other. We know them both. Then find one where we know the one but not the other. 77 and p, they are opposite, and we know one of them. This is perfect. Now we can manipulate this. Look for the variable. Is it on top or on the bottom? If it's on the bottom, let's do a flip. So 68.3 over sine 56 equals p over sine of 77. All right, we see that the sine 77 is underneath our variable, so we are going to cross that out and put it over here, and make sure you put it on the top. And p is simply equal to sine 77 times 68.3 divided by sine of 56 equals approximately 80.27. Now this is lowercase p. It doesn't say sine p, like sine of big P. So this is definitely not an angle, and we don't have to do sine inverse because it's not sine of something. It's just straight up p. So we're done. We know that little p, the side length, is 80.27. All right, this would be a good time to take a screenshot, and we're going to move on to the next question. All right, I've changed all the values in this triangle, and we're going to do the same thing, but if you notice this time, we have an angle, an opposite side, and another side, and we're looking, we don't know the other two angles. So you can't just say 180 degrees minus 64 minus, well, you don't have another thing. So these two things we know are going to add up to 116 degrees, but we don't know what each of them are. We need to find one of these two angles. Okay? But we're going to follow the exact same steps. Step 1. Find an angle and its opposite side, making sure that we already know the value of both of them. So we need to find that. So I see here big H, little h. I don't know big H, I don't know little h. Well, that's a far cry from knowing both of them. Don't use that. Big G, little g. I know little g, but I don't know big G. Can't start with that. Big F and little f. I know big F and I know little f. 64 degrees, 80.6. Remember, they're opposite to each other and we know both. Boom, we start with that. So if you look over here, one of the sides is sine of 64 degrees divided by 80.6. Right? Now the other side, we need one but not the other. We need opposite sides again, but we know one but not the other. So here we have big H, little h. That's not qualifying because we don't know either of them. Big G, little g. Boom, we know the one, not the other. So the other side is going to be sine of the angle, which we don't know, divided by the side, 75.9, which we do know. Okay? Now we've already solved that. The G was already on top. We crossed this out and brought them over here. Sine of G is equal to approximately 0.8464, and sine inverse you had to do in this case. When you're finding an angle, remember this doesn't say G, it says sine of G. That's not good enough. We need to know what the actual value of the angle is. So it's sine of some angle equals 0.8464. And you can actually double check. If you go to if you just put in your calculator sine of 57.8, that's the thing that's going to give you 0.8464 approximately. I should have an approximate sign right here. Let's change that. All right, so we know that 57.8 is G. Well, now we have two different angles, so we can actually find the third angle. Angle H is simply equal to 180 degrees minus 57.8 minus 64 degrees. So H is 58.2 degrees. All right, one more time. Find an angle on a side that we already know. Well, that's easy. Sine of 64 and 80.6. And find an angle on the side where we know one but not the other. Well, I know 58.2 degrees, but I don't know H. right? So let's set it up again. Sine of 64 degrees divided by 80.6, those are the two I know, equals sine of 58.2 degrees divided by h, those are the ones where I know one but not the other. H is on the bottom, unfortunately, so let's flip it over. 80.6 degrees divided by sine of 64 degrees equals h over sine of 58.2 degrees. As you guys know, we're going to cross out the sine of 58.2 degrees, move it all the way up to the top, not to the bottom, and we have sine of 58.2 degrees times 80.6 divided by sine of 64 degrees equals h. Therefore, h is equal to 76.2 approximately. Now, this isn't sine h. That wouldn't make any sense. You can't take the sine of a side. It's always sine of an angle, right? So there's no need to do sine inverse here. H is actually equal to 76.2, and we're done. All right, I'm going to do a couple more examples, but now this time, we're going to try to use a sine law, and we're going to see that sometimes the sine law isn't going to do. Because for the sine law, we need an opposite angle and side. If we don't have that opposite angle and side where we know both of them, we're going to have to resort to the cosine law. All right, here we see we have a triangle. We know that there's a 55 side length. There's another side length of 63 and another side length of 76. Notice I don't know the value of this angle, or this angle. None of the angles. So first thing I always think of is try to use a sine law. To do the sine law, if you remember, we need a side and an angle. We have to know both of them, and they have to be opposite to each other. Well, that's impossible because we don't know any of the angles. So I know 76, but not this angle across from it. I know 63, but not the angle across, and I know 55, but not the angle across. We can't use the sine law. We now must use the cosine law. All right, the cosine law, I gave two equations here, but it's really the same equation, just rearranged. And the reason I want to give you this equation in two different forms is just it makes life a lot easier for you, because if you're looking for an angle, like we are in this situation, we have all three sides, we're looking for an angle. Well, I rearranged this equation here so that the cos of A is by itself on the left. Right, so I had to subtract b squared and c squared, and I had to divide by negative 2bc, and then I multiplied top and bottom by negative 1, and so I got it all rearranged so to be nice and tidy with the cos of A by itself, and we do know b squared, c squared, a squared, b, c. We know all of these values because we know the side A, B, and C. Right, so when we plug it all in, it'll be cos of A equals, and we'll just get a value there. Because it's cosine of A, I know this value is going to be between 0 and 1, or 0 and negative 1, but it's going to be a small number. All right, first things first, let's name these angles. Let's call this M, N, and P. I don't like to use O because it looks too much like a 0. And that makes this little m, little n, and little p. And we are going to follow the cosine law, but as you can see, there's A, B, and C. So instead of A, B, and C, we're going to use M, N, and P. But we just have to make sure that whatever letter we use as whatever angle we're trying to find here, this one says A, so this is the opposite side. So if I'm trying to find big M as my angle, well then little m has to go in this spot, and then N and P can go in these two spots. If I'm trying to find P, well then little p has to go in this spot, and then M and N can go in these two spots. Right, so be very, very careful. It really matters that this capital letter is an angle that is opposite to this lowercase letter. There's a reason they're the same letter. All right, let's just use this one. We're going to try to find the angle M to start. So let's just start plugging things in here. We have cos of M is equal to n squared, so that's 63 squared, plus p squared, so 55 squared, minus little m squared, 76 squared, all divided by 2, also divided by n, which is 63 again, also divided by p, which is 55. So put that in your calculator, and the cos of m is equal to approximately 0.1758. Notice it's a small number between 0 and 1. Cos of m and sine of m will always be between, negative 1 and 1. So between 0 and 1, but positive or negative. All right, well, we're not done. That's the cosine of m, right? We're not going to have the actual angle m in our equation. We have the cosine of m. So to find the actual angle of m, we need to take the cos inverse of 0.1758. So I'm going to take the cos inverse of what I already have in my calculator here, and the cos inverse it gives me 79.9 degrees approximately. So m is approximately 79.9 degrees. Now, each time I calculate a new side or angle, I like to ask myself again, do I know two angles? If so, I can find the third angle. In this case, I still don't. I know one angle, but not the other two. So I can't use the 180 degrees minus the first angle minus the second angle to find the third. The next question I always ask myself is, do I know a side and an angle, like both of them that are opposite to each other? And in this case, I do. I know an angle here and this side, so 76 and 79.9, which means I'm done with the cosine law. I can now go right back to the sine law. We can do that quickly because we've already gone through this in the video, and we have sine of 79.9 degrees is divided by 76 is equal to the sine of, let's say, big N divided by little n, 63, and we're going to rearrange and move that over, find that the sine of n is equal approximately 0.8161, and which means that capital N is equal to approximately 54.7 degrees. Of course, we just did the sine inverse of what we got here to get that. And now all we have left is angle P, so we can just do 180 degrees minus 79.9 degrees minus 54.7 degrees to get angle P is equal to 45.4 degrees. All right, our triangle's solved. We use the cosine law, followed by the sine law, followed by the whole three angles add up to 180. And let's just double check, make sure our greatest angle is opposite the greatest side. So let's see, 79.9 is our biggest angle, and 76, sure enough, is the biggest side. The smallest angle is 45.4, and yep, the smallest side is 55. And the middle angle, 54.7 degrees, is opposite the 63. So I feel good about that. All right, in our last example, we're going to have another situation where we do not know an opposite angle and side. So we can't use the sine law. But also, we don't know all three side lengths. We know two sides and an angle. All right, so let's take this triangle right here. Again, you can see we can't use the sine law because we know an angle, but we don't know its opposite side. We know a side, but not its opposite angle, a side, but not its opposite angle. So we don't have a pair of angle and side that are opposite to each other that we know. So we're going to have to go to the cosine law. But also, we don't know all three sides. We know one angle and two sides. Right? So we're going to find the third side first. And that's the situation where you're going to use this form of the cosine law, where the side length that we're looking for is going to be by itself here. Right? It's going to be squared, so at the end, we're going to have to take the square root, right? Because we're going to find out what a squared equals, whatever this is. Right? Now, keep in mind, so this is little a, you have a big A. So whatever I happen to name this side, it's going to be a lowercase letter. This 39 degrees has to be the angle that we throw in here. Right? So let's just name this, let's say GHI. That makes this side little g, this side little h, and this side little I. All right, and this is the cosine law where we're trying to find a side length, not an angle. So we're going to start off with h squared is equal to little g squared plus little I squared minus 2 times little g times little I times the cosine of 39 degrees, which is big H. Notice I've got little h here and big H here. Just like in the equation, we have our little a and big A. So we have the cos of the angle, and the side we're looking for is opposite to that angle. All right, let's quickly fill that in. H squared is equal to 128 squared plus 113 squared minus 2 times 128 times 113 times the cosine of 39 degrees. So h squared is about 6,672. And we don't want h squared, we want h. So we're going to have to take the square root of both sides, and h is approximately 81.7. All right, you guys could probably finish the rest of this triangle. Pause the video, try to do it, and unpause when you're done. And I'll go through the rest just to make sure that you know what you're doing. Anyway, so every time I I find a new side or a new angle like I just did, I found 81.7 here, I think about it again. Do I know two angles? If I know two angles, then I'm just going to hurry up and find the third angle by doing 180 degrees minus the other two. If I still don't know two angles, like here, I know 39 degrees, but I don't know the other two, then I'm going to check, do I know a side and angle that are opposite to each other? Well, yes, I now know 81.7, which is opposite to 39 degrees. So I'm going to use that, and that means I can now go back to the sine law. So quickly, sine of 39 degrees divided by 81.7 is equal to the sine of, let's say, g, divided by its opposite side, 128. Remember, when you do the sine law, the angle and side in each one of these fractions has to be opposite. So 39 degrees has to be opposite to 81.7 on the triangle, and it is. The g and the 128 have to be opposite on the triangle. They are. You have to know both of the ones on the left here, and we do. And you have to know one of the two on the right. So I know 128, but not g. That's perfect. Okay, I can isolate g by getting rid of this 128, putting it over here. And then the sine of g is simply equal to 128 times sine of 39 degrees divided by 81.7 degrees. So sine of g is approximately 0.9860. And of course we have to take the sine inverse of that to find g, and it is approximately 80.4. Alright, that's another thing we solved. Let's go ask ourselves the same question. Do we know two angles? Oh, yep, this time we do. So easily we can find that third angle. 180 degrees minus 39 degrees minus 80.4 degrees equals 60.6 degrees, which is I, and we have a solved triangle. Just to double check, make sure that the biggest side is opposite to the biggest angle, the smallest side is opposite to the smallest angle, and the middle side is opposite to the middle angle. They all are good here, so I feel pretty confident about this triangle.